Welcome back. This is where networking starts getting really interesting because everything you've built so far now needs to be defended. In Lesson 42, we're stepping into Stage 6 with security fundamentals, the core ideas every network professional has to internalize. We'll work through the CIA triad, learn how to think in terms of threat models, and explore the layered philosophy known as defense in depth. So here's the roadmap for the next few minutes. We'll start with the CIA triad: confidentiality, integrity, and availability. The three pillars that every security decision ultimately ties back to. From there, we'll look at who's actually attacking your network and where they get in, then layer on defense in depth as a way of thinking. And we'll close with the practical principles that hold modern security together: no AA, least privilege, and zero trust. So let's start with that first pillar. Actually, three pillars working together. Confidentiality means only the right people can read your data, protected by encryption and access controls, threatened by eavesdropping and leaks. Integrity ensures data hasn't been tampered with. That's where hashing and digital signatures come in, defending against modification and man-in-the-middle attacks. And availability guarantees authorized users can actually get in when they need to, backed by redundancy and failover, undermined by DDoS or ransomware. Notice each one carries a trade-off. More secrecy costs usability, more trust costs performance, more uptime costs money. Security is always a choice about which matters most. Now, knowing what to protect is only half the picture. You also need to know who you're protecting it from. Threat actors range from the script kiddie chasing bragging rights with downloaded tools, all the way up to nation-state APTs wielding 0 days and infinite patience. In between sit cybercriminals chasing ransomware payouts, hacktivists making a statement, organized crime running funded operations, competitors after trade secrets, and, often the most dangerous, the insider who already has the keys. Your defenses should match the actors who actually target you, not a Hollywood version of hacking. Once you know your adversaries, the next question is where they can actually reach you. And that's your attack surface. Think of it as every door, window, and vent in the building. The perimeter handles public services like web and VPN, defended by firewalls and DDoS protection. Endpoints, laptops, and mobile devices need EDR and patching. Cloud APIs demand least privilege IAM and configuration audits. And don't forget internal lateral movement, vulnerable web apps, and the human layer, where phishing and MFA decide who wins. Less surface, less risk, always. Now, since we know attackers have many ways in, the smart response isn't one perfect wall. It's many imperfect ones stacked together. That's defense in depth. Perimeter firewalls catch the obvious stuff. Network segmentation contains what gets through. Endpoint tools protect the devices. Application controls guard the code. Encryption shields the data itself. And asset management keeps you honest about what you're protecting. The math is beautiful here. If each layer is just 80% effective, 6 layers together reach 99.99%. Attackers have to beat every single one. Defenders only need most to hold. Now zoom into one of those layers, access control. And you'll find a pattern called AAA, the 3 questions every system should ask whenever someone tries to do something. First, authentication. Who are you? Prove it with something you know, have, or are. Second, authorization. Now that we know you, what are you actually allowed to do? That's where roles, attributes, and policies decide between deleting and just reading. And third, accounting. What did you actually do? Logs, audits, timestamps. Because without that trail, you can't investigate, prove compliance, or even know you've been breached. With AAA in mind, let's step back to the principles that shape every security decision you'll ever make. Least privilege says, give the minimum access needed. Admin should be the exception, never the default. Zero trust takes it further. Never trust, always verify every single request. Fail secure means when things break, they break locked. Firewalls default deny. Doors lock when power cuts. Separation of duties ensures no single person can approve and execute or code and deploy. And finally, assume breach because you will be compromised. So design for detection and containment, not just prevention. Now, if you're going to assume breach, you need to know what you're up against. These 9 categories cover most of what you'll actually see in the wild: phishing and malware hitting the human and the endpoint, DDoS and MITM targeting the network layer, brute force and SQL injection probing your authentication and your applications. Notice the pattern in the defense column. It's never one control. Phishing needs training plus MFA plus filtering. Malware needs EDR plus patching plus segmentation. That's defense in depth showing up in practice. Layers, because any single layer will eventually fail. Listing attacks is useful, but to design defenses systematically, you need a framework. And Stride is the classic one. Microsoft built it as 6 categories that map cleanly onto the security properties we've already discussed. Spoofing breaks authentication, tampering breaks integrity, repudiation breaks non-repudiation, information disclosure breaks confidentiality, denial of service breaks availability, and elevation of privilege breaks authorization. So for any system you're designing, you walk through these 6 and ask, how could each one happen here and what layer stops it? Frameworks like Stride help you find threats, but in practice, most breaches come from the same handful of avoidable mistakes. Treating security as an afterthought makes it expensive and weak. Bake it into design reviews instead. A single password protecting everything. Add MFA and hardware keys like FIDO2 for admins. Flat networks let one compromised laptop become a full breach, so segment with VLANs and internal firewalls. Change every default credential, and critically, invest in detection because prevention will fail, and the industry average to notice a breach is still over 200 days. So let's pull this lesson together. Security rests on the CIA triad: confidentiality through encryption, integrity through hashing, availability through redundancy. And you defend it by matching your controls to the threat actors you realistically face. Stack your defenses in layers, because any single one will eventually fail. Apply the 3 A's, authentication, authorization, and accounting, to every access, every time. And internalize the mindset: least privilege, zero trust, fail secure, separation of duties, and always assume breach. And here's your cheat sheet. Everything from this lesson on one page. Keep this nearby as you work through real systems. When you're configuring a firewall, designing an auth flow, or reviewing an incident, scan down this list and ask which principles apply. The CIA triad up top, the 3 A's in the middle, and the mindset principles at the bottom. That's the mental model security professionals reach for every day. That wraps up our foundations of security, but the journey continues. Next up in Lesson 43, we move from principles into practice with firewalls, looking at stateful inspection and next-generation firewalls that form your first line of defense at the network edge. I'll see you there. And if you're following along, Dargslan.com and the YouTube channel have the full series waiting for you.